Alright, here we've got finding the components of a vector. In this example, the directions say to calculate the x and y components of a vector given below. Do not round any intermediate computations. That's really important. You can't round any intermediate computations or your answer will be off. You only round your final answer to do 2 decimal places. Alright, so what's that mean? Calculate the x and y components of the vector. Well, what that means is we want to get the xy components for this endpoint. Okay, let's take a closer look. The x and y components of that endpoint, we're given some information. Notice in this current problem, the initial point is at the origin. So of course that's 0, 0. That's nice. Gives us a good starting point. And so all we need are the x and y components here. We know this angle, 62 degrees, and we know this distance, which is 11. So how the heck are we going to figure out the end components? Well, we're going to revert back to our nice functions here. If we were to draw some dotted lines to make this a nice right triangle, then we can see that this distance is the x distance, or the x component, and the height here is the y distance, or the y component. And we can use our lovely SOHCAHTOA, and we can see tangent's not really going to help us, but sine and cosine are. We know that the cosine is the adjacent over the hypotenuse, so the cosine of this angle is the adjacent over the hypotenuse, x over 11, and our sine is the opposite over the hypotenuse, so the sine of 62 can be the opposite over the hypotenuse. It gives us y over 11. So these are equations that we can actually solve for those x and y coordinates, or those x and y values. So let's take a look. If we've got the cosine is equal to, the cosine of 62, my bad. Let's fix that up. The cosine of 62 is equal to x over 11. Then we have to multiply both sides by 11 to get 11 times the cosine of 62. That's the x value. And the same thing with the sine. If the sine of 62 is equal to y over 11, we just multiply by both sides by 11. And that's how we get this 11 sine of 62. Now, in your calculator, you just put in 11 sine 62 equals, and then you round to the nearest hundredth, because that's what the directions say to do, and that gives us our answer. Let's take a look at another quick example. So again, finding the components of a vector, calculate the x and y components of this given vector. So basically, we're just looking to find the x and y value of the endpoint. How do we do that? Well, if we were to make this a triangle, a nice right triangle, right? Then we would know that this distance is the x value and this distance is the y value. And once again, using our trigonometric functions, we can say that the cosine of 75 degrees is going to equal the adjacent over the hypotenuse, that's x over 80. And same thing for the sine of 75 degrees, that's going to be the opposite over hypotenuse, that's the y over 80. So we can solve each of these for the x and y value. we know that in order to do that we just need to multiply both sides by 80. Over 1, these cross cancel. We're just left with the x and the y. So when we do that calculation, x is going to equal 80 times the cosine of 75. That comes out to be 20.7055. And the y is 80 times the sine of 75. That comes out to be 77.2741. 2741. Now, a couple of things to notice. First of all, we're in the negative realm here, right? Both of these have to be negative, and we have to round to the nearest hundredth. So what's that give us as our final answer? X is going to be negative 20.71, and our y is going to be negative 77.27. And that gives us our final answer right there.